Algebra of functions and composition of functions is our topic 2.8. Just like numbers, you can add, subtract, multiply, and divide functions. Just like almost the way you do with numbers, we can add, multiply, subtract, divide. Okay? So this is the representation of how we do this. This is in the question. Oops, I'm sorry. Just needed to restart. So shortly we represent addition of two functions, function notation f, function notation g, but they are both together under the same parentheses, and then another pair of parentheses comes and x is in. So when you see this notation, I know, okay, I must be adding them because of this plus sign. Basically what you do is you pull the formula for f, expression for f, you pull also the expression given for g in the question, and you just put a plus, and then you start combining like terms, simplifying, subtracting any negative, positive terms, okay? And get your result reduced down as much as possible. So similarly, you do the same operations with subtraction, multiplication, and division. Everything is very smooth, except when you're dividing one function into another, we need to prohibit that g can never be 0, because if g becomes 0, a number over 0 or expression over 0 is undefined. So we want to avoid the locations g is 0. We will exclude them from the domain. Okay, let's take a look at our first homework question. This is from my set. Yours is a little bit different, but it should be addition as well. They want us to simply, what do they want? I know that this notation means add. They want us to add f and g and create a third function out of them, new function. Basically, they want the equation of f and g, put it together with a plus, combined together with a plus in between. All we need is find out what f is, find out what g is, and put a plus in the middle. So what is f? G. So x squared plus 1 is the answer. Okay. So the first question is just very simple. Checking back if you get the idea of what addition means. You basically add those two formulas given for each function. Next part, however, they want us to sketch and find their new graph. When you add them, you got a brand new graph, right? And don't go with the options, solutions presented there. Find your own graph. Can you graph this? I mean, we already know x squared graph, right? Isn't this parabola right between x and y, right? Now what happens if you add 1 to it? It moves up 1 here. So I need to go pick a graph starting at 1, 0 instead of 0, 0. I'm sorry, 0, 1 instead of 0, 0. This is down. Is this 0, 1? Seems so. There are two answers here, correct? Oh, this is not a parabola though. This is 0, 1. This is the parabola. The answer seems right. Seems like part option B. Where do we choose it though? Down here. Okay. All right. Our first question is over. And we will do other operations next. This next second coming one is, what operation do you see here now? A subtraction between g and h only. So you will not need this one. Yeah, we can cover it. We only need G and H and a minus in between. However, there is a distinction here, something different. So in the first question we have addition, now subtraction, that's fine. What else is different? Yeah, instead of x, you have here a number. So how does our method change? Not much. Look, if this was x, I would put here g of x, h of x, their formula each, and put a minus in between, right? Now instead of x, I have 3. Is it minus 3? Yeah, it's minus 3 actually. So instead of working with x's, I'm going to flip these notations into minus 3's each. Alright? So when I'm using the formula of g, expression of g, I won't use this one. It looks like g is that, right? But I won't be using it. Why? Because there is no longer x inside parentheses, right? What is it now? Minus 3. So I will take an eraser, clean this up, and put back what? This. Right? And same way, instead of copying the formula of 1 over x plus 4, I will skip x. Instead of x, I will enter minus 3, because that's what I see here. Are we done? We need to simplify this as much as we can. What is minus 3 minus 5? Negative 8. What is absolute negative 8? There is an absolute value around it. It's positive 8. Negative 3 plus 4 makes 1. What is 1 over 1? 1. 8 take away 1 is 7. There we go. Okay? Alright, it has only one part. Great. Let's move on to the next question. I believe we're going to start multiplying next. No, it's division. Again, this symbol means divide h by g, create a fraction between them. However, I don't know if this is a good thing or not. I think it's a good thing. We have a number instead of 7. Hi. That's alright. I'm glad you made it. Okay, now how do I do this time? If this was just regular x's, I would put the formula of h on the top, g on the bottom. I would just create a fraction with their formulas, right? H is this thing, look. H, I'm reading h, I'm putting right here 1 over x plus 3. G, read g, we don't need f by the way. G is absolute x minus 5. This is h over g o x if it was asked. It wasn't. What is asked then? They want instead h over g with 7. All you need to do is flip this into all x's into 7. So it's 7 plus 3. And instead of x minus y, I have 7 minus 5. Okay? Well, we're not gonna leave it like this, of course. We will complete these operations. I have 7 plus 3, which is 10. I have 7 minus 5, which is 2. Absolute 2 is 2. Are we done? How do I simplify this thing? Okay, I have a feeling 10 is 5 and 2. I can cancel 1 2's from here and get 1 over 5 over 1, which is 1 over 5. Do you agree? You agree? Why? I mean, it looks like I just canceled. 10 is split into 5 and 2's. 2's common, I canceled them. Right, this is incorrect. Unfortunately, it seems like it makes sense, but no. This is a fraction you have here. I mean, 10 and 2 are not on the right spots. 2 is on the numerator of a bottom fraction. Consider it as 2 over 1. 10 is in the denominator of a top fraction. So they are not on the same side, so you can cancel. I wish it was 10 over 1 on the top, so I was doing it right, okay? So if you have two fractions like this, separated by a main big fraction, I always recommend doing this. Turn this is called complex fraction, and this is the main body of the fraction. Mark it really well. I just want you to turn this into simple fraction simply by flipping this, flip, and multiply with the top. Multiply with the top. So this is what I mean. 1 over 10 is the top. I flip the bottom, which is 2 over 1. When you flip it, 1 over 2, and it is 1 over 20. Instead of getting less 1 over 5 in the denominator, it enlarges in the denominator, it becomes 20. 1 over 10 is split 2 more ways, it's 1 over 20, okay? That's the right way. Again, the rule I applied here is if you have a over b, c over d, complex fraction like this, you flip the bottom and multiply with the top. So it's AB times D over C. You flip this, okay? Okay? Did you know this? Good. Alright. I want to test something else though. What if this was 3 over 2/5? Let me mark the main body of the complex fraction. How would you do this? Yeah, just imagine 3 as 3 over 1 and a fraction by another fraction, and then you still flip and multiply the bottom. Multiply this, it's 15 over 2. Okay? If top or bottom, either one, has one fraction, you always flip and multiply. That's the safe bet. Some people can do this on top of their head. That's fine. But I go with the safest option. Alright, so what is the result? 1 over 20. That's number 4. You can do number 3 on your own. If I'm skipping it, that means there is nothing new in there. You can do it with the past knowledge. Alright. I always move right and left with the keyboard because mouse is not precise. It's hard to get to the desired location, so use the keyboard arrows if you have a mistake and you need to fix it. Alright, are we good so far? Look, we're not doing anything different than what we do in numbers. You see addition, you add the formulas. You see subtraction, you subtract the formulas. If you see product, guess what I'm gonna do? By the way, this is a product between who, R and Q. I will cover the middle one and we will never need it, okay? But in your set it can be R and P maybe, so you may need the middle one. So R and Q is multiplied, and the formula says if you see the dot R cube X, you need to just write R and Q and put a multiplication dot in the middle. Simply replace R by the given formula, Q by the other given formula, and simplify if possible. Do you see any kind of simplification, any cancellations, reductions? No. So this just multiplies and they combine into this. Okay? So this is the multiplication. However, the question is not over yet. We need to write the domain in interval notation. And we haven't talked about domains yet. Let's talk now. Again, these are operations: add, subtract, multiply, divide. However, you always get a new function, brand new, more complicated function, something new obtained, and its domain may be different than the previous functions, f and g. So what's the new domain then? The new domain, you just created a new function, and its domain is always the intersection of those individual functions. So you will spot intersect those two separate domains, f and g domains, and you need to see what's overlapping between them. Okay? That's first way. And by the way, if you are dealing with division, you need to also avoid all the points that makes g 0. Or if you don't want to find individual domains of R and Q here, immediately look at the final product and try to find the domain from the final product if you already obtained it. Okay? Look, minus 7x root 2 minus x. Are there any bad values that we must avoid here for x that can make this thing undefined? Domain is, again, the set of all x's you're allowed to enter into the square root and x. What x's are good? If there are some bad ones, you must exclude them from that interval. Are there bad values? Let's first compare this one, or in other words, this one. Are there any bad values that makes minus 7x malfunction or fail? Does any bad values you enter into 7x and it can make undefined? Can I enter 0 in 7x? Yeah, 1, 1 over 2, 1 million, negative 0, negative 10. Yeah. So everything good, all good with this one. R of x is a healthy function, it never breaks down, right? This one is fragile. It may get hurt if you put the wrong x in it, right? What are some bad values you can pick for x and it makes this square root fail? Give me something. 3, for example. What is 2 minus 3? Negative 1. Can you compute square root negative 1? We cannot take square root of negative numbers. Negatives are bad. So 3 is bad, 4 is bad, 5 is bad, 1 million is bad. So we need to find all those bad values and compute the good ones. So here is all numbers. Now you spotted 3. 3 is here. I spotted 4. 5. 10. Is this all? It can be 3.1, 3.2, 3.5, right? They are also bad. So it has to be all these red marked things are bad. So is the bad guys list here all? Did I cover them all? No, there are more. Right? Maddie, do you know more?
Anything greater than 2.
Anything greater than 2 is as well bad. Like 2.1, 2.2, 2.3, 2.8, 2.9, and 3. So I need to start with 2. But 2 is good, so I'm going to put a parentheses there. 2 is good, so I'm excluding it. It's a good guy. This red is the bad list. Red is the bad. This entire interval is the bad. But domain is the set of good values. This is bad. If this is the bad region, what is the good region then? Domain. What you need to enter into part 2 in your domain interval is not this red colored region. It's wrong. This is bad one. We need to put the good list there. So where is the good list? If all values on the right are bad, then all values on the left is, I'm sorry, if all the values on the right is bad, the good guys should be on the left. So I'm going to take this and everything left. Look, I'm covering 2 and everything left to the left up to minus infinity. This is the good side. This is the domain. These guys won't hurt the square root or q of x actually. It won't hurt it. So the good guys are on the left starting with 2. Why? Isn't 2 bad? When I enter 2 here, this becomes 0. Root 0 is computable. It's good. Root 0 is 0. Alright, this answers our second part. First one was negative 7x. This is how you make square root again. 2 minus x. Interval notation domain is this, right? All right. Moving on. Any questions? We are done with the 4 operations. Any questions? Add, subtract, divide, multiply. Here comes the next one. 5th and newest operation. And you don't see this in numbers. You can't compose numbers. This only specific for functions, and this is very important. Okay, compositions of 2 functions is first of all denoted by this little circle. It's not a dot, it's an empty circle here. Yes, when you see this, oh, I'm composing something, you either see this notation or this notation, either one. So this is option 1. You see this up or this. The option 2, what's the difference? It looks like the circle notation is gone and G went inside of under the belly of F. Look, this is F parentheses. This red pair of parentheses is for F. So whatever is inside is F is like consuming it. It's like F is a big fish, G is a little fish inside the F fish. But G has, this is G, its own belly, and G also consumed a tiny little fish called X. So just imagine what F and G are. I called them fishes now, but they're like buses. Passenger goes here. X is your passenger. X is you guys. You take a bus first. It's called G. Go to somewhere. And then immediately once you step out of the bus, there is another bus behind you. You take that bus. It's called F. And you go to your final destination, home, for example. Okay? Do you understand? So this is a chain of 2 buses. Usually you have one bus, X you guys write in this bus and go, for example, 5, right? You enter 2 with the bus F and go to 5. But this is double bus. Passenger first gets into G, and G process that passenger, and then wherever he is landed with G, he immediately gets onto the other bus F and reaches at final destination. Okay, this is another way to describe it. With machines, X is our initial passenger, goes to the first machine or bus, and machine gets a new product, and that product goes into second machine, and that second machine gives us the final product. So you can make your own real life example. I used fishes, I used buses, and now machines. So functions are those. Functions are converter, transformers. They transform one input value into another. And there is a double one here composed. So it's a two-step machine. Okay? I will show you how we evaluate it though. I will show you how they process literally a number, a passenger. Okay, what do you see here? This is the question. What letters do you see? G, F, and a passenger 3. Okay, so I'm going to cover H. H is not going to be used in this question. Alright, what do? I locate my passenger first. Where is he? He's in the center, 3. And look immediately at the first letter next to it. This 3 is inside F. It's under the value of F. Look, do you see the parentheses of F? These parentheses, tiny parentheses, belong to F. So F is gonna process 3. So literally on the side, process F of 3. Okay, I start here, G, F of 3. I see that I must first process this. 3 is processed by F. Do it on the side. How do you compute F of 3? Perfect. We plug in 3 everywhere you see in X. So it is 3 cubed, 8, and 3. And this way I know where passenger 3 goes with this bus F, which is 27 plus 24 totals to 51, right? Okay, so I can now remove this and replace it with 51. Your passenger 3 is gone and turned into a 51 passenger. So passenger 51 is gonna take this G bus. Now you have, instead of F of 3, G of 51. Does it make sense? Now how do I compute G of 51? I need to compute where 51 goes with this G bus. What shall you do? How do I compute G51? We enter 51 in X in G formulation, and that will make, this is 3 times 17, but it won't matter. No, 255. First try to break everything into factors so that maybe you can get a double factor so you can bring it out of square root. But 3, 7, and 5 are all different factors. There is no square of them. So if there is no square, you just combine them all. 5, 3 times 7 is 255. And that's it. This is our answer. Okay, here comes the new question. However, the difference here is, first, the notation is different, but even though it looks different, I can make it just like the previous question. This notation means M is in the center, the second letter is always in the center, Q is outside. M is in, Q is out. So this passenger is first processed by function M, then the result is processed by function Q. Make sense? Alright, this is a little bit different. Now put Q in. You always need to compute this guy first, right? Correct? Where does X go with M? Now, who can tell me the result? You're sending X into M, and I wonder where it goes. Any ideas? If this was 5, you would enter 5, right? In M. But it's X. So what do you do? Ashley, do you know? Chris? Okay. Yes?
You add the whole function in for X.
Yeah. Don't change nothing. If you still see X here, if it's not turning into number, then leave it alone. Leave it as it is. M of X is this, then take that and place it here. Okay? Alright, next. Now, here comes, this is essential. Please listen up what I'm doing. If Q has only X in here, only X, it will transform X into 1 over X minus 12, right? Correct? Do you have only X here? Something else, right? Whenever you see something else, first thing you're gonna do is copy the formula of Q, because we are operating under Q, copy it, but everywhere you see X, leave an empty box, because it's no longer X. Do you see only, but only X here? No, then leave out all those spaces. Make sense? Alright, then what do I put back in then, if I can't use X? Yeah, whatever you see here is gonna replace each and every X on this side. Functions notations work only with substitution or replacement. If you see X, you make X's here. If you see chickens here, you make chickens there. That's it. That's as simple as it is. So what is my chicken here? Root X minus 7. So you put that here. Okay? Basic replacement. Okay, we're done. Let me clearly write it down. Oh, can I subtract minus 7 and 12 and make minus 19? No, one inside a prison, the other one is free. They can't come together. Okay, they're not like. So this is the best we can do in part 1. The question is not over. Oh, this is 8. By the way, you can do this on your own. It's very similar to 6. So first make a fraction. We have a fraction answer. Top is 1. Bottom is square root X minus 7. Go out with the arrow key and type in 12. Okay, we are gonna determine the domain of this new thing you just created. You created a brand new function here. If you wish, you can call it z of x. It's new. Here is your z of x. what is its domain? What are the good values you can enter here? So you need to think bad values and remove them. Alright, take a moment. Alright, anybody has an answer? Part 2, you're gonna find domain. Can somebody describe in words what numbers are good or what numbers are bad so we can find the good ones? What are the bad numbers? Such as 10. Is it 10 good? Yeah, 10 is good because 10 minus 7 is root 3. Root 3 minus 12 is a new number, whatever it is. It's good. Now, are there numbers you can compute? You cannot compute?
Anything less than 7.
Anything less than 7 is bad. Like 6.999 minus 7 is negative, right? 6 is bad, 5 is bad because 5 minus 7 is negative. So we want to stay positive, right? Must be 0 or more. 0 or more is good. So bad numbers are less than 7. So again, let's visually mark them first. These are bad, 7 and less. Okay. So what are the good values then? 7 and more is good. Correct? When you end, so the answer is 7 to infinity. Do you think? If you type this in, it's gonna say incorrect because we're missing another view. You need to also consider something. This function is not just the square root function. You are right if the function was only root x minus 7. There is another fragile function here when you look at the whole picture. What's fragile here?
You can't divide by 0, so you use 151.
Right, this is a fraction. We must avoid denominator equal 0. We don't want denominator to be 0. Are there any values you enter in x, subtract 7, compute square root, and it becomes 12, and you subtract 12 from it and it becomes 0? What number you put into x, subtract 7, take square root, makes it 12? So here is the question. You don't have to guess this, compute it. Again, what number x minus 7 I put into x and subtract 12 makes it 0? This is what you need to solve. So how do I solve this? Add 12 first, right? Now I need to get rid of a square root. What's the right weapon to cancel a square root? Perfect. What is square root of 12?
24.
Good. And then I add 7 to both sides. And voila, you caught the bad guy. 151. It was hiding in the good, among the good people. Where is 151? Here makes our function sick. When I enter 151, I get 1 over 0 undefined. So I need to exclude it. So our interval is not this. It has two pieces. One is before 151, the other one is second. So our whole line, green line, is broken into two pieces. You need to write it in two pieces. The first one is 7 to 151, parentheses, don't include 151 because it's bad. Skip 151 and continue your way up to infinity. Got it? Let's test. Alright, so it's going to be a union of two intervals. I use the union symbol here. Okay. Very good. That's a tricky question. Most people just focus on the square root, forget about the fraction. We must pay attention to that. Alright, next question, number 9. Okay, this is a comprehensive question. It pretty much checks out, it has 7 parts, you see. Checks out everything we did so far on a graphical approach. We add functions, divide, subtract, compose, compute their values, not through the formulas, but through the graph. Look, the difference is we don't know m and p in values, in formulas. I wish they were given to me like this. M and p not given. What is given instead is just their graphs. Okay? How do we do this? Alright, just go with trial and error. Try yourself. There is -3 to be computed once you add m and p. And then supply me the answer if you have one. About this question. Okay, m plus b minus 3 notation means, this means you compute m at -3, p at -3, compute them separately and add them up. You're adding them. -3 goes into m, -3 goes to p, and you add them. Pretty much 4 operations is like this. Now I need to compute m of -3. Passenger -3 writes the m bus, blue bus, and see where he goes. So find this passenger on x-axis. Where is -3? Going to the left. Here we go. And where does this guy go? It's already on the curve. You need to go up and down and hit the curve. I don't need to go up and down to hit blue curve because it's already on it. So just read the y coordinate. What is the y coordinate of this dot? 0. So it went to 0. How about p of -3? Alright, p of -3. I need to now, same passenger. So go to that passenger and hit the pink curve and read that point. This is the point you hit. And check out its y coordinate. It's 4, right? So p under p -3 goes to 4. And 0 plus 4 is 4. Right answer is 4. Okay? Alright. Next we are subtracting p minus m at 0. P minus m at 0. So you need to compute p of 0. You need to compute m0 and subtract them. Anyone? Any new people?
-2.
Alright, we got -2. Any different answers? I believe it's -2 then. No objections, but let's double check. 0 is the passenger. First takes the bus at P. Where is P? P is here. That's 2. And then it takes the M bus, which is the blue bus. It goes up here, and that's 0, 4. That's 4. The right answer is 2 minus 4, -2. Good. Part C. We have division of M and P at 3. Order matters though. Check out who is on the top and who is in the bottom. Don't do P over M. M over P. So that means we're going to compute M of 3 and P of 3 and look at their ratio. Interesting. Any answers?
It's undefined.
Undefined. Because M of 3 is, here is 3, I go up and hit M and look at its Y value, it's 2. P of 3 is, oh, this is already on P, so it is 3, 0 is 0. And 2 over 0 is, you cannot divide a number by 0, undefined. It's not on the domain. 3 is not in the domain of this function. Alright, multiply at 0. So that means you compute M0, P0, multiply them, which is, haven't we computed 0 values already before? It's right here, 2 and 4, right? Put it backwards though, 4 and 2, but it won't matter. The answer is 8. Okay, so far these are boring. Now it gets challenging. Circle operation. What does circle mean? Composition. Right? We need to slow down and take a look at this. Palm 1. Let's first translate what this circle means. It means 1 is first traveling with M. You're getting a result, and then that result is traveling later with P. Okay? So in other words, what I mean is P is waiting outside. That's the second turn. Second turn is P's. But first turn is M. M gets a chance with 1. Alright? So you are going to transform 1 with M. Do it. Find passenger 1. Where is passenger 1? Here is passenger 1. Send it to M. Where are you? M, blue one. Blue bus. Passenger 1 takes this bus and see where it goes. Where does it go? It's 4. This guy, M, took 1 into 4. So you have now P of what? 4. Now you have a brand new passenger in the second bus. 4 guy. It's gonna take this bus. So find the new passenger 4. Where are you? Here, right? On X. And send it to P. And it's this one. 1. Am I right? No, I'm wrong. I picked the blue one again. It's the old one. No, you can't use the old bus. You need to use the new one. Wait a second. The new one doesn't operate on that route. It can't, you see, it's empty. 4 pushes the door, wants to go into bus. Bus says, no, I don't go that part of the town, right? Because it's empty, right? So it's not in the domain. 4 is not on the domain. Bus won't allow him to ride on, okay? So what do we do? What do we say here? Yeah. We don't have where 4, bus can't take 4 in. Alright, last 2. This time the passenger is switched to 3. Be careful, the order of buses changed. So who is first 3 is riding into? P instead of M earlier. Now it's P. If you change the order, the answer will also change, okay? So F is M up 3. In other words, M is second. P gets to carry 3 first. Let's see where he goes. Where does he go with P? 0. Alright, here is my passenger 3, and it's already on the bus, P bus. So let's read its y coordinate, which is 0. This guy is 0. So P took 3 into 0. Now 0 rides on M. What is M0? Yeah, it's 4. Whoa. Why did it say wrong? I probably checked it twice. Hit this one too, but we got it right. Alright, this time we are... Wait a minute, what is this notation? They didn't use the circle notation for composition. They directly used the second one I already make all the time, right? So this is P circle M O minus 1. P circle M of minus 1, just like part C, part 5. Part E, part 5, okay? But we have minus 1. So here's what's asked. They are asking for P of minus 1. Right? P M minus 1 is asked in part 7. Which is G. Alright, let minus 1 travel with M. Goes with M to where? Minus 1. Here's minus 1. I'm taking which bus? Blue bus, right? And I'm going to... Alright, let's write P now. Well, I can't, right? It's empty. This is 4. I'm trying to get into P undefined. All right. We're done. Any questions?